Hey everybody, it's Mr. Carr again. Today we're going to be talking about 2 for day 2. We're going to continue our work with our zeros of a polynomial function. Okay, we're going to look at them in a couple different ways, but bottom line is we're going to do a couple different things with them than we did in the previous time. So one of those things like this is going to be writing a k of x function as a product of linear and irreducible quadratic factors. The irreducible quadratic factors means we cannot factor it any further. Now, maybe it's just not factorable. We have something that's irrational, or maybe they're complex. They cause complex roots. So for this function, before I do anything with this, I'm going to go to the graph and see where does it cross the x-axis. That is going to be my zeros that makes this process a little bit easier. Okay, so for example, we have -3. So we know we're crossing at -3, -2, and 4. These 3 zeros are going to help me get this reduced down to a factored form. The other part of this to be aware of is the fact that with these 3, we notice that there's no multiplicity. So I don't have like a repeated factor of -3. So I'm not going to take that to the second power. We also see that since there's no multiplicity, that leads me to believe that we're going to have 2 complex zeros that we're missing from this. And that's what's going to bring us down to our quadratic. So let's use the -3. We know it's crossing at, -3, 0, -2, 0, and a +4, 0. Okay, so I just pick any one of these. I'm going to start with my synthetic division. I'll start with -3. So I'll list out all my coefficients. We've got those right there. So we got 1, 1, -13, -23, -14, and -24. Okay. So go run through my process here. We got -3 times 1 is a -3. Combine those to a -2. Multiply -3 times a -2 is a +6. Combine those, I get a -7. Combine these, or multiply these, we get +21. Gets me to a -2 here. This will be a +6. Combine that with -14 is -8. And then combine it or multiply -3 times -8 is a +24. My bad. There. Okay. +24, and I get my 0. And that was expected. Now this went from a 5th degree down to a 4th degree. I'm going to use another 0 and just repeat the process. So I'll do this one in blue just to keep it a little bit separated. Okay, so I'm going to do the same exact process for -2 now. So drop the 1, multiply those, I get a -2, so that's a -4. This will be a +8, so that's a 1. -2, so that's again a -4 here. Multiply those, I get 8, and there's my 0. So again, that's what I was expecting to happen. And then let's finish off with my 4 as my last 0 that I know from the graph. So I'm going to do the same thing here. Okay, so we bring down the 1. 4 times 1 is 4, so I'll 0 that out. 4 times 0 is 0, so that gets a 1. 4 times 1 is 4, so that gets my 0 there. So all this work here to tell us this last part, which is 1x squared plus 0x, so I'm not going to write it, plus 1 equal to 0. Or I don't need the equal 0 part. But this is what my final part is based on these coefficients right here. X squared plus 1. So using our known 0, let me scroll up a little bit. Our known zeros here, we're going to rewrite this k of x function as the factors x, let's see, it crosses at -3, so it's going to be x plus 3, x plus 2, x minus 4, x squared plus 1. So this is my, let me scoot it down a little bit. There's my k of x function as it's all factored out and irreducible quadratic factors. Now, the next step, I'm actually going to do the same exact thing, but instead of having it as irreducible quadratic factor, everything's going to be in linear factors, meaning everything is going to be x plus or minus some value. Now, you notice, again, I'm expecting to have complex roots here. So first thing I'm going to do is I'm going to take my, there we go. Let's take my function from earlier. I'll rewrite that. And let's just focus on this x squared plus 1. We need to take that broken down. Now, it does not factor. So instead, we're going to do this. We're going to solve x squared plus 1 equals 0, any method you want. So one way I can do this is I can just subtract 1 over. So I have x squared is equal to a -1. and then I square root both sides. So that's a plus or minus. Now I want to remember, with the square root of -1 here, that's the same as I. So really, it's x is equal to a plus or minus I here. So it does not factor, but I can actually turn this into x plus 3, x plus 2, x minus 4. I'm going to do x plus I and x minus I. Okay. If I were to take this and multiply this back out, it'd be x times x is x squared. Negative xi, positive xi will cancel each other out. And then negative I squared turns into a positive 1. So that'll take me back here. So everything is in linear factors, including my complex zeros. Okay. So let's use another example here. So find all real and complex zeros of this function, p of x equals x to the fourth minus 6x cubed plus 35x squared minus 50x minus 58, given that x equals 2 plus 5i is a 0. Then write the linear factorization. So we're doing the same thing. I'm already given 1 0, and I'm given a complex one. Technically, I could go and graph it to find any real zeros, but maybe they're all not complex, but maybe they're all irrational, possibly. So what I'm going to do is this. I'm going to do my synthetic division still. I'm going to put 2 plus 5i because that is what's officially, that is my 0 there. So I got 1, -6, 35, -50, and -58. Okay, so let's run through this process. It's just going to be a little bit more complex using the i's in there. So that's a 1, 2 plus 5i. If I distribute the 1, it's just going to be 2 plus 5i. Combine these together, I'm going to have -4 plus 5i. Okay, now I need to multiply this here. I'm going to distribute that. That helps you just right off to the side. So I got 2 plus 5i times -4 plus 5i. So I distribute the 2, I'm going to get -8 plus 10i. Distribute the 5i, and I get -20i, and then positive 25i squared. So this will turn into a -25. I can combine that with a -8. So I'm going to have a -33. And then I have 10 minus 20 is going to give me a -10i. Whew. All right. So 35 minus 33, I can combine those two values, and I get a positive 32 minus 10i here. Okay. So once again, I'm going to take this and distribute with this. So got 2 plus 5i times 32 minus 10i. Okay, we'll distribute that. We got 64 minus 20i. So 32 times 5 there will be a positive 160i, and then -50i squared. So again, that turns into a positive 50 from that, from the i squared. So this will turn into 64 plus 50 is 114. Minus, nope, no, plus 140i. Should give myself a little bit more space with this last number. Just shift that over a little bit, -58 over there. Okay, so I can take -50 plus the 114. It's going to give me 64 plus 140i. So we're going to go ahead and do the same thing. We're going to distribute the 2 plus the 5i times 64 plus 140i. Okay, I need to go back a little bit. I'm sorry about that. I just realized I went a little too quickly with my thought process here. Okay, I don't know why I wrote 32 there. That messes up a lot of that. Okay, so after doing the distribution there, it should have been, let's see here. It was, let's see here, 2 plus 5i times a -4 plus 5i. That was a -33 here. -33 minus 10i. When I combine these two, that just comes out to a positive 2. I don't know why I wrote 32. Probably just got a little bit distracted there. So 2 minus 10i. Okay, so now I am going to distribute, and it's going to be distributing with the 2 minus 10i and the 2 plus 5i. So I'm coming back here. So when I do that, that's very different. Okay, So that's going to be 2 times 2. Well, 2 times 2 gives me 4, then minus 20i, plus 10i, and then minus 50i squared. Okay, so again, this is still a positive 50. So that I combine that with the 4, and that's going to go to 54. And then these two will combine as a negative 10i. Okay, combine these, negative 50 plus 54 is going to give me a positive 4, oops, and then a negative 10i there. So I'm going to multiply this out, 4 minus 10i. 2 times 4 is going to give me 8, and then negative 20i, positive 20i, and then negative 50i squared. So these actually will cancel out here. So I'm left with 8 and then plus 50 to give me 58. So I do that and I get my 0, which again, I expected. Now, the thing to remember is since we have this right here, 2 plus 5i, then that means my other 0 is going to be 2 minus 5i. That's my other complex one. So we're going to repeat this process with 2 minus 5i here. And let's just do the same exact thing. Oh, there we go. All right, so we got 1 here. So this will be 2 minus 5i. Combine these, that will actually cancel out the i's. So I'm going to be left with a negative 2. Then I got 2. If I distribute the negative 2 to the 2 minus 5i, that's going to give me negative 4 plus 10i. So again, my i's will cancel out. 2 minus 4 is a negative 2. And then I multiply that by a negative 2 again. So I get a negative 4 plus 10i. And I canceled those out all to 0. So we got 4's cancel out and 10i's cancel out. All right, so we're almost there. Now what I end up with is, because I start off with x to the 4th, and I've taken away or I divided out 2 of my zeros, I'm down to x squared. So 1x squared minus 2x minus 2. That again. Okay, so if I want to factor this a little bit further, I'm going to look at how can I factor x squared minus 2x minus 2. Well, unfortunately, that by itself does not factor either. So we're going to have irrational zeros as well. Now, your choice on how you want to solve this from here, you can do completing the square, or you can do, I think I will do completing the square, but you can also do quadratic formula. I don't have as much space for the other one. So I'm going to set this equal to 0. And for completing the square, I'm going to have x squared minus 2x plus blank. I'll bring the negative 2 over here. So it's a positive 2 now, but plus another blank here. I'm going to add the same thing to both sides. For that c value, I'm going to do b, take b divided by 2 squared. So in this case, that's going to be a negative 2 divided by 2 squared. So negative 2 divided by 2 is negative 1. Negative 1 squared is 1. So I need to add that to both sides here. So that means I can factor the left side into x minus 1 squared equals 3. From here, I'm going to square root both sides, so that x minus 1 equals a plus or minus root 3. And then when I solve that out, I get 1 plus or minus root 3. So how does this look in my overall factorization? You need a little bit extra space down here. So what I have is, okay, so I've got my 2 plus 5i is a 0, 2 minus 5i is a 0, okay? And then I've got 1 plus or minus root 3. So remember, in my factored form, this was p of x? Yeah, p of x. In my factored form, it's going to look like this. X minus 1 plus root 3, x minus 1 minus root 3, x minus 2 plus 5i, and x minus 2 minus 5i. I want to simplify this a little bit. Let's get rid of those extra parentheses by distributing my negatives there. So my p of x written as a complete linear factorization is going to be x minus 1 minus root 3, x minus 1 plus root 3, x minus 2 minus 5i, x minus 2 plus 5i. And that is the end of that problem there. So again, dealing with these zeros can be some very complex problems, and not just dealing with complex zeros, but because of all these extra steps that we have to take. But bottom line is we're going to use our synthetic division to help guide us to the end parts of this one. All right. So use your known zeros or finding zeros from the graph. Use that to help model our factoring and get through that problem there. All right, that's it for today. Take care, everyone.